Here we have a set of data in StatCrunch that gives us graduation rate and income by state. And the question comes up, are these related? And naturally, we would assume that the higher the graduation rate, the higher the income. So let's find the linear regression model that relates these two variables. And remember that it will take this form, y hat equals a plus bx, and we'll assign x as the graduation rate, and y will be our income level. And what we expect then is this explanatory variable x will have an effect on the response variable y. And we expect that to be a positive effect. So if we were to look at hypotheses then for testing that relationship, our null hypothesis would be that beta is 0, and our alternative hypothesis would be that beta is greater than 0. We expect there to be a positive relationship there. In other words, we expect that as graduation rate goes up, income level should go up. At this point, it should be stressed again that causation is very difficult to prove. The significance that is being tested is not for causation, but rather the relationship exhibited by the sample. Remember that beta is our population parameter for which B is our estimating sample statistic. Now we can perform this test using the TI-84 calculator. The first thing that we would want to do is enter the data values into the lists. A couple of things that we would want to make sure is that all of the conditions are met for performing a linear regression. And we'll look at a couple of them. Let's look at the graph for the scatter plot for the ordered pairs in the data set. And then let's look at the residual plot. So to look at the graph, we'll press second stat plot. We want to look at a scatter plot. I'm going to begin by turning plot 2 off. So I'll access that plot and I will turn it off. Then I'll go back to my stat plots and I'll see that there aren't any that are on. Let's turn one on. So we'll access that stat plot. The type of plot that we want is a scatter plot. So we'll make sure that that is selected. We have our graduation rate in list 1 and our income level in list 2. So those are appropriately assigned. Now we'll push graph. And we'll need to make sure that we get this window right. So let's push zoom. And then zoom stat 9. And here we see the scatter plot. And there appears to be an upward trend in this data. There certainly isn't a perfect linear correspondence, but there does appear to be an upward trend. Let's look at the residual plot. In order to look at the residual plot, we'll need to make sure that our diagnostics is turned on. So we'll do that by pressing second 0 for catalog. And then we want to get down to the D's, and we can do that by pressing alpha D twice. And then we'll scroll down here once we get to the D's until we get to diagnostics on. And we'll hit enter. And then we'll hit enter again. So the diagnostic program is on. Now I'm going to want to do a linear regression. So I'm going to push stat. I'm going to go over to calc. I'm going to hit 4 for linear regression and hit calculate. Now we'll not pay attention to this output. What we will pay attention to is the stat plot that we are going to generate in plot 2. So I'm going to turn off plot 1 and then go back to second y equals for stat plot, and then go down and access plot 2. So I will turn this one on by highlighting on and pressing enter. Make sure that we have our scatter plot selected. We have our x values in list 1. Now we want to make sure that in the y list we have the residuals selected. And your calculator probably won't have that already selected, and here's how you would get to it. We'll press second stat, and then after turning the diagnostics on and doing the linear regression function, we should have the residual selection. So we'll select that, and then we'll go to graph. It doesn't appear in this window because our zoom isn't correct, so we'll push zoom 9 again, and there we go. There is our residual plot. And it does appear that we have a random scattering of data values around the line y equals 0. Not exceptionally random, because we do have some values that appear to be a bit outlying up here, but not too bad, especially for this small of a data set. So now let's go to stat, tests, and then we'll go to linear regression t-test. And when we do that now, we're going to make sure that we get our correct lists for our x and y variables, which they are oriented correctly now. We also want to make sure that we get our alternative hypothesis direction correct, and then we'll come down and hit calculate. Now we have a t-test value. We have a p-value. Degrees of freedom is 23. We have a and b, which are our y-intercept and slope. We have our coefficient of determination and our coefficient of correlation. We could also get these values nicely using a program like StatCrunch or Minitab or something like this. We'll go down to stat, regression, simple linear. We'll select graduation rate as our x variable and income as our y variable. We'll come down here to hypothesis test. We want to test the slope. We want to test if it's greater than 0. And then we might plot the same things. We might plot the fitted line and the residuals versus x values. And when we look at the graphs, we see pretty much the same thing. We see this upward trend, and we see that when we look at the line y equals 0, we do appear to have a random scattering of data values above and below, no fanning kind of an effect, although we do have these values that appear to be kind of high up here, or maybe even just this one. And we get this table with all of the output that we need to answer some questions. We would have y hat equals 15357 plus 346 if we round to whole numbers, x for our predicted linear regression. We have a t-test value of 2.483, and we have a p-value of 0.0104. We need to note that this t-test value, if it is not given on a computer printout on a problem, can be found by dividing the slope by the standard error. Now, this p-value of 0.0104 tells us that these two variables do have a significant linear relationship.